Hello everyone, it is Ahmed Fouad and today we are going to discuss how to provide an asynchronous version from an already legacy synchronous function. Let's take for example this JSON convert.serialize object, and now for some reason we need to make it non-blocking call. We want to make it asynchronous, and JSON.NET doesn't provide such capability. So one of the most popular code is to just wrap it inside Task.Run. And then now it is asynchronous. The only problem with that is that task.run means that you are going to move this execution to the thread pool. So by every time you are calling this function, you are grabbing a new thread from the thread pool, doing your logic on it, and then returning it again, which can hinder a lot of performance and a lot of memory allocations. Because imagine this function is getting called 10 times, so you are grabbing 10 different threads, you are redoing the allocation on every one, and then you are returning it. One of the other problems is that the thread pool is limited, and if you do that all along your code base, you can overwhelm the thread pool and then ending up stacking to find a new threads. Here we are going to try to make it using a different way by having a dedicated thread that processes this serialized object. So we'll have one front thread that can receive request, one background thread that will do the processing, the normal way that an asynchronous code can run. So let's make a new class. Let's call it async JSON serializer. And in our new class, we need to have a worker thread. So now let's create a new worker thread. So thread dot new background processing. That's our function. Let's create it. Let's say worker thread. So that will be our worker thread. Can't work. And we need our asynchronous function that will receive the data. So let's have a function that return a task of string that, let's call it serialize async, that will receive an object. Now what we need to do is to pass this object from this serialize async to the background processing and then get the result and move it again. In order to do that, we will use the blocking collection. So let's declare a blocking collection, and the blocking collection of course will need a record type. So let's create a type that will only hold this object and the result. Let's call it serialization request or serialization artifact, that matter, and save it. It will contain the parameter and the result. Completion source. And now what we will do here is we didn't create the background collection. So let's create it. Let's initialize. And now here let's create a new task completion source. string 1, and then let's insert in our collection. I need the object and the corresponding task completion source. And finally, let's return task completion source dot task. And in order to access these items in our background thread, we will use get consumer in Marble. And then here we can say implementation request task completion source dot set result JSON convert dot CSS object. And in case an exception happen, we need to forward it. Let's set exception. And now we need to start. Now background set. Now this get consuming in Marble is a blocking call. It will only terminate when the collection has processed all the items available and is completed. So we need to mark our class as disposable class. And here, before disposing the collection, we need to mark it as complete adding. So this in Marble can finish and then the thread can be released. Of course, we don't wanna release the class and disposing it before every item is getting processed. So we need here to wait. So here we need to wait until all are processed. You can do that using different ways. One of them is using thread.join, but I prefer using semaphore. So I will use semaphore slam. Initialize it. And initial count is 1. And here now, here we're gonna release it after everything is done. And here we will use it to wait. We can use wait. Oh, let's make use of the new async disposable. This should be value task dispose async. And then it need to get disposed. So now time to benchmark and do our new class. Oh, this is on. Now time to benchmark, and let's put our code in comparison with the thread pool one. So I will use benchmark.net. Let's create a benchmark. Apply class. Async serialization benchmark. And I will have a function. I first need that, so it is not getting allocated every time. And I will create the first function, which will be task.run based. Async task. Let's call it thread pool based async. And in my thread pool based async, I will just copy this code. And I will have an instance of my async JSON serializer. And now I will create a function benchmark worker thread based async. And I will make it wait serialize string, and I will put file. And here, because this is disposable, contains the disposables to be disposed. And of course, let's mark it as benchmark. And I want to put the memory profiler to see if there is difference in memory. Now let's run our benchmark. Benchmark runner dot run, and I will put, let's see. What I expect may be a slight difference in time, but the memory allocation will be pretty similar. And after that, we will run a different benchmark that might show some difference. But let's see first what we will get. So we are back. The allocated memory is quite similar, and we are slightly faster, that's only some nanoseconds. But this is a little bit optimistic benchmark, because this code will be called multiple times in your code base in the real one, not just one time. So let's simulate, for example, that our function is getting called 10,000 times. Let's fix the indentation. And here the same. So let's try again now and see if there will be any significant difference. So we are back. There is a big difference in time. It is like 5 milliseconds for something, and the memory allocation is less 1 megabyte. And 10,000 time is not a lot, so imagine that it is a web application. You decided to make your JSON serialization async. This will get called more than 10,000 time. The only difference between both of them, just to put it in context, the Task.Run will pick any thread from the thread pool, will ask him to do the job, and then will free him. While our managed implementation, having a dedicated thread, that's our worker thread, it will be that our jobs will get queued and then get processed by him. So we don't need to deal with reallocating for every thread some objects. We don't need to deal with freeing the thread after we are done and this stuff. That's why it is faster and it allocates less memory. The only drawback that we will address in the next video is if we're gonna run them in parallel, then of course task.run will beat because it will keep grabbing threads from the thread pool and then it can run more than one serialization in parallel. While our implementation is always will always queue them in the blocking collection and then they will get processed one by one. But that's a different topic and we will address it with a different strategy. Let's say that for async you need at least two threads, one foreground that receive request, one background that process. But for having parallel we'll need to have more than one background thread to do more processing. Thank you everybody and I hope a nice day for you. If you like this video please subscribe to my channel. Thank you.